The microdamage formed during orthodontic miniscrew insertion has been strongly associated with site-specific remodeling. During the remodeling process, the bone implant contact might reduce, potentially resulting in orthodontic miniscrew instability. It's thought that by minimizing the amount of damage formed during insertion, the clinical success of the miniscrew might be improved. Therefore, the aim of this study was to investigate the influence that cortical bone thickness has on the amount of microdamage formed during orthodontic miniscrew insertion. 30 bone specimens with nominal thicknesses of 1, 1.5 and 2 millimeters were created from porcine tibia bone. 1.5 by 6 millimeter R-house orthodontic miniscrews were used and a sequential staining technique applied. Xylin or orange was used to identify residual damage. Calcium was used to distinguish insertion damage, and calcium blue was used to identify damage caused during the removal of the orthodontic miniscrew. A laser confocal was used to image the specimen. The confocal microscope has the unique ability to image a specific focal plane, and this is of great importance as the introduction of iatrogenic damage can significantly impact on the results. The images were then quantified into total damage area, diffuse damage area, maximum damage radius, maximum diffuse damage radius, and maximum crack length. All orthodontic miniscrews inserted into 1 millimeter thick bone. 8 out of 10 orthodontic miniscrews inserted into 1.5 millimeter thick bone, and none of the orthodontic miniscrews inserted into 2 millimeter thick bone. The orthodontic miniscrews that failed to insert only pierced through the bone specimen, and the orthodontic miniscrew collar failed to make contact with the bone surface. Further insertion wasn't able to be achieved as maximum torque was reached. Despite the incomplete insertion, 2 millimeter thick bone demonstrated statistically significant total damage area, diffuse damage area, maximum damage radius, and maximum crack length, compared to the 1 millimeter and 1.5 millimeter thick bone. These results can be attributed to the design characteristics of the orthodontic miniscrew, which has a pitch of 0.69 millimeters. Therefore, in 2 millimeter thick bone, 2.9 threads would interlock, compared to 1 interlocking thread for 1 millimeter thick bone. The increase in number of threads embedded into the bone would undoubtedly equate to an increase in micro damage, as the bone is displaced by the cutting characteristics of the thread. The greater amount of micro damage associated with 2 millimeter thick bone biologically might equate to extensive remodeling region adjacent to the orthodontic miniscrew. To reduce the amount of microdamage and achieve complete insertion, a pre-drill protocol is advocated. The difference in microdamage observed between 1 millimeter and 2 millimeter thick bone provides the histological evidence to support the pre-drill protocol. The main findings of this study reveal that an increase in cortical bone thickness is strongly associated with an increase in microdamage formed during insertion. Clinicians are advised to consider the cortical bone thickness when inserting an orthodontic miniscrew in order to minimize unwanted microdamage.